I invited 7 game developers to compete in the IndieDev 500. Get it? It's like the Indy 500, but with indie devs. A couple years ago, we simulated the World Cup, and since then, I've been cooking up a way to do something similar, but bigger and better. This time we have more devs, and to open this up to any dev regardless of the tools they use, I've made a custom visual scripting system that turns finding the best racing strategy into a game. The devs have 29 total blocks they can use, but the core functionality for the cars is in these 6. The most important one for the competition is the controller. This block accepts 2 values, one for throttle and one for steering. Each cart can get data about the world from 3 forward-facing sphere casts. Each dev can control the size and distance of these sphere casts, but the angles are set for everyone at -30, 0, and 30 degrees. When a sphere cast hits something, they'll display as red, otherwise they're green. Around each track, there are invisible waypoints devs can reference as well. Each dev has 20 stat points to customize their kart's max speed, acceleration, and turning. All the developers have received 1 track to train on and an example solution that they can choose to reference or not. They've all been given 90 minutes to find their solution, and the clock starts now.
Hi, I'm TheShelfman and I'm bad at visual scripting. But since I've spent about 700 hours playing the Formula 1 games, I still think I should win this competition. Once I had opened the project, I had to really study Aya's example card to know what tools I had and what strategies were available. Seeing the spherecast nodes, I quickly realized that I wanted to try something I had learned when I first started programming. I used my spherecast to check whether I had hit a wall. Actually, that is not entirely true. I actually make my spherecasts long enough that they always will. So I don't care whether it hit any, I just care which wall is closest. And depending on which one is, I move in the other direction. This is perfect for turns, but on straights, I admit it does look a little silly. And while I broke the project several times trying to figure out how to properly let go of the throttle for certain turns, I eventually went with a safe bet and used the front sphere cast to determine my current speed. Visual scripting is hard, but the Dutch will never give up. At least not this one.
We're here at the qualifying round for this year's IndieDev 500. The lap times will be averaged for each car to determine the matchups in the tournament. Each new round will introduce a track the competitors have never seen, and the winner of each race will progress until we found the champion of this year's Turing Trophy. The qualifiers will take place on this training track. After the first 2 turns, there's an elevated section that goes into a hairpin curve. After that, the track snakes around under the elevated section and back to the starting line, where it looks like the Shelfman is ready, so let's get into the qualifiers. Coming up on the first lap here, 25:59. Final lap time for the Shelfman of 1 minute and 11 seconds. Now we just need to do that for everyone. But our final competitor is not like the others. This one is controlled by my wife. Yeah, I gave her a literal controller. She'll be racing on behalf of humanity. It should be interesting to see how someone with advanced reasoning, but without the aptitude of a gamer, will fare. After simulating all of the cars in the qualifiers, we now have rankings based on average lap time. For reference, I've included the sample car as well. Most of the competitors had slower times in the example, but a slower, more reliable strategy may prove to be beneficial in the long run. Remember, the tournament has 3 new tracks that no one has been able to prepare for. Maybe DualWielded and KotieDev have something up their sleeves.
Yo, so my strength is not at all AI. I don't think I've ever really made any, or, at least nothing remotely exciting. So if we... And I just... Do you think he would know? Would he know? My plan was simple. I just want to use the 3 sphere casts to see where the walls are, then I only want to steer as soon as there's something directly blocking the road in front of the car. The closer you are to the wall in front of you, the slower you go and the more you steer. And this went pretty well. It felt like the car was following along the path pretty nicely. This Stupid ramp. I hate it so much. The car just picks up too much speed and you can't possibly make it over, so I made it check the difference between the Y coordinate of the front and the back of the car to determine, if it's going downhill or not, and then make it literally drive backwards. It won't be able to, but it will put force in the opposite direction, making it slow down just enough, hopefully. Please?
180 miles an hour around the outside.
Dude, that took so long,
of the 130.
All three spherecasts see a wall at the same time, and the car has no idea where to go. When this happens, the car slows down really hard, checks if the next checkpoint is to its right or left, and then just steers full force that way until one of the spherecasts is fine again. That's when the normal steering and throttle calculations can take over again. The car crashed many times while messing around with the values, but in the end, he finally made it through 3 laps, and I was happy. He didn't even beat the example card though, so,
Hey everyone, I'm KotieDev. Let's get into what I was up to. I started off by setting a 90-minute timer. I made a new car, and then I just tried to see what I could do within the time. After playing around with the nodes, I ended up with a giant mess, and then I heard this. Oh no, I cannot be out of time yet, I'm not done. I had ran out of time before my car was fully done. Instead of describing my problems, I'm just going to show you what I ended up with. Clearly this car just sucks. Unfortunately there's a hard right turn bug, and I also just didn't have time to tweak any of my values, so we've ended up with whatever this is. On the bright side, it's quite consistent and I don't think it really hits any walls, so that's a plus. Hopefully another car gets stuck at some point and I manage to beat them.
From the rankings, I've created our final bracket. The map for the first round is a figure 8. Competitors start on an elevated platform, loop under it, and then back up to an elevated turn. Coming off of that elevation is a fast turn into some squiggly wobblies, and it's straight back to the starting line. Our first matchup is Mrs. Aya versus Lighthoof Dryden.
Hey, it's Lighthoof Dryden. Thank you so much to this AIA guy for having me on here. At first, I wanted to create a simulation that reflected my personal Mario Kart playstyle, but there weren't any edges to drive off of, so that was out. I tried a couple approaches. First, this sort of naive implementation that just looked for walls and tried to avoid them, but that didn't work out so well. So I started having the kart always looking for the next waypoint by using a point on its right and left side and doing some vector math so that it always steered toward it. This one was the first successful kart to make it around, and I call it the Wiggler. Then it was time to shave some seconds off. Unfortunately, the wiggling had to go because it got in the way of the momentum. I replaced it with this smoother turning calculation. The main goal is to get as much speed as possible on long stretches while not getting stuck on corners. Using the sphere cast, I got the distance to the wall ahead and then divided it by a max distance so that the car would ease off the gas as it got closer to the wall. The down ramp is dangerous because you can pick up too much speed and then crash into the wall. So to compensate for that, I used a point that's right in front of the car, and when that's lower than the car itself, I know that I'm going down and to ease off the gas. After tuning some stats, I was able to beat the Aya Mobile by at least a few seconds each time. But then I started loading in more karts to test a lower frame rate, and not knowing what the final race is going to look like, and without the access to the delta time or the angular or linear velocity of the kart, I decided to go for a more cautious and dependable approach. The literal opposite of my actual racing gameplay. So, we'll see how it goes.
Out of the gate, both racers come down the hill and Mrs. Aya runs into the corner. Lighthoof is making good time, taking these corners very nicely. Mrs. Aya is still stuck at the first turn. Lighthoof seems to be using a calculated strategy, not a ton of speed, but a lot of precision. Mrs. Aya seems to have gotten things figured out and is very carefully inching her way through the elevated portion of the track. Lighthoof finishes his lap 2, and Mrs. Aya eventually makes her way to finish her first lap. Not too long after, Lighthoof finishes his last lap, and this one comes to an end. Lighthoof wins in a landslide and will move on to the semifinals.
Wow, I lost. Shocker.
Our second matchup features DualWielded against the superstar from the qualifying rounds, Hedgebyte, whose slowest lap time was faster than the second-seeded Primer's fastest time.
Hey everyone, I'm Zach, also known as Hedgebyte. and I was just going to tell you a little bit about my car. I used the left and right sides of the car to detect how far away those were from the center of the next waypoint. If the right side is longer, I take the left side and I subtract it from the right side, which means I get a negative value, and I can input that into the turning, which makes it so it turns left. And the same is also happening on the right side, except the inverse, where if the left side is bigger than the right side, I get a positive value. Similarly, I measure the distances in between each of the waypoints, and if it's a small distance, I know that it's a tight turn, so I kind of cut my throttle. One big other thing that I made sure to do was if the waypoint is underneath me, I slow down a little bit, which may end up eating me on some other courses. Anyway, that's my car. Just wanted to let you know about it.
Out of the gate, it seems like Zach has a much faster car than DualWielded. Despite both racers navigating the course without hitting anything, this may be an uphill battle for DualWielded. He's navigating the course fine, but Zach seems to be doing everything with so much more confidence. A big slowdown from DualWielded at the end of this hill. The gap between him and Zach is increasing every second. Zach finishes his third and final lap. Hedgebyte is moving to the semifinals.
So the BlobMobile has no idea where these walls are because it doesn't use collision detection. All it knows is which direction is it facing and which direction does it want to be facing to get to the next waypoint. And using these two vectors, it does a cross product, and that cross product will either be up or down depending on the relative orientation of these vectors. And then that is what it uses to turn left or to turn right. And that's really the core of it. There's of course a little bit more going on here, but this is what's happening with the cross product. Unfortunately, Aya didn't make a cross product node. I don't know why. Anyway, but yeah, you can also see that it does no collision detection here.
Primer has no problem taking the first turn. Kotie's not colliding with any of the walls, but it seems like each turn is taking him a significant amount of time. The BlobMobile, on the other hand, is flying through the course. It's about to lap KotieDev here. Primer finishes his second lap, and Kotie is closing in on his first. This particular turn seems extra difficult for Kotie. He is able to course correct and finish his first lap right before Primer finishes his last. Primer moves on to the semifinals. It's time for the most anticipated matchup of the first round. The average lap times of the Shelfman and Biegs were less than 0.3 seconds apart. This one should be close.
Okay. Let's drink and drive. So I'm going to take the tried and tested man approach of not reading any instructions and just seeing what I can do. So, what's this do? Well, so far my main complaint is the lack of any kind of grid snapping on these nodes. My OCD is going to make this thing take like 5 times longer. Get it together, Aya. Okay, first test run. If I've done this right, we should just go straight forwards. There's no steering yet. When it gets to the wall, when it detects a wall, it should brake. Dead simple, straightforward. What could go wrong? Well, holy hell. Okay, so what I'd like to do is make it variable, and hopefully that way it will gradually slow down as it approaches an obstacle. This is fine. I mean, this is kind of working. If we just overlook the fact that we're going the wrong way. Never mind. Okay, so I was trying to be too clever, and I made it so that the steering was variable. So the faster you were going, the further the steering sensors reached out. That didn't work. So I've simplified it a bit. I think we might have it. I'm going to press go. Let's see what happens. We did a lap!
Biegs is great off the line, but it looks like Shelfman is better at taking the first 2 turns. But Biegs takes the lead before turn 3. He's established his lead as he completes the first lap. coming down the hill, he has too much speed and ends up colliding in the corner. This, folks, is why you don't drink and drive.
Let's drink and drive.
This ends up being Biggs' final resting place. What looked like such a promising start ends in disappointment. The Shelfman glides to the next round. Round 1 is now complete. 4 competitors have been eliminated and 4 remain. This track for the next round will really benefit the fastest cars. It's about as simple as you can get. Just 4 right turns, creating a single loop. First up is Hedgebyte versus the Shelfman. Early on in this race, Zach is taking a healthy lead. Coming up on turn 3, and he hits the tires here. Shelfman able to close the gap a little bit, but very quickly Zach back on track. We're on lap 2, and Zach is approaching that tricky turn 3. He brushes into the tires, but it doesn't really impede any of his progress. Not great news for the Shelfman, as he won't be able to use that to make up lost time. The general lines for Shelfman look much tighter. His lack of ability to gain momentum seems to be costing him. Zach is on the final lap and he does collide at corner 3, but at this point the gap is so large it doesn't make much of a difference. Shelfman is eliminated and Hedgebyte moves to the finals. The last matchup of the semifinals, Lighthoof Dryden seeded 3 versus the second seeded Primer. In the second turn, Lighthoof seems to have lost a lot of momentum, took it a little bit wider, and Primer pulls away a little. Very similar racing lines from both of these competitors. Seems like out of the corners, the BlobMobile is doing slightly better. Both of these cars actually have the same attributes, so the smoothness that each of these are able to come out of these corners and keep their acceleration up seems to be making a fair amount of difference. Primer takes this one and moves into the finals. I just want to take a second here and point something out because it's kind of a controversy. For all of these races, I simulated them together and then went back and I simulated them again to get additional footage to use for different angles. But in this particular race, I couldn't do that because every time I resimulated it, Lighthoof actually ended up winning. There's a lot of variables at play here, but I don't know, should he have been the one that moved on to the finals? Despite a bit of drama, we're here at the finals, and this last track is a bit of a doozy. It's significantly longer than the other courses in the tournament, which means there's more time for our finalists to make mistakes. The track starts with this wibbly wobbly bit that transitions out into an elevated section. This is the only track in the tournament that has a full turn on an elevated platform. The elevated platform then ends with a tight left turn. Every turn out of a ramp up to this point has been a right, so it could be a stumbling block for either of our competitors. From that, we go into a snaking section that leads into the mountain. A quick change in elevation that will send our competitors around a bend and into a long straightaway. It's possible here for our drivers to reach significant speeds, which they'll have to manage into the last couple of turns before ending back at the starting line. The number 1 seeded Hedgebyte in blue against the number 2 seeded Primer in light blue. Zach is taking the first turns incredibly slow, so Primer is able to gain an early lead. Only a single stat point difference for the cars in this one. Zach has it in speed and Primer has it in turning. With the variety and length in this course, it will be interesting to see how this shakes out. Zach is closing the gap but collides with a barrier and loses some ground. The turning stat seems to be the difference so far. This long stretch could be an opportunity for Zach to catch up. A bit of a wide turn from Primer. Looks like he lost grip at the end of it. A much better line for Zach allows him to finish the first lap in lead. 0.58 seconds between them after lap 1. Zach is being overly cautious yet again in this windy section, which allows Primer to regain the lead. Zach again gaining ground, but this time he collides with the tires. Primer seems to be very consistent in his route. We'll see how that fares at the corner he slipped on in the first lap. Zach is able to regain some ground and finish the second lap in the lead. However, Primer had a better lap 2 by 0.4 seconds, so it could be either competitor's race. Another good lap from Primer could give him this win. So far, this lap is looking identical to lap 2 for both competitors, which isn't great news for Zach. He needs to make up time or he'll be going home empty-handed. Coming up to the final turns here, and Primer slips up again! Hedgebyte wins the Alan Turing Trophy. Congratulations to Zach. What an exciting last match. If you think you can do better or you just want to make your own AI, the project that I sent all of the competitors is available on the Discord. There's also a supporter version with some additional features like being able to control the F1 cars with a keyboard or gamepad, and it has all of the tracks in this tournament. Thank you to all of the competitors who joined. Make sure to go check out their channels in the description. A special thank you to all the Patreon supporters and YouTube members. If you found this interesting, you'll also enjoy the time we had 6 devs from around the world compete in a simulated World Cup.